box. Okay, blue box. Here we go. So what we're asked to be doing today, boxing properties generally related to bases. So looking at bases, yesterday we talked about acids. Now remember, bases are going to be, just like we said here, are going to be those bleach, shampoo, soap, toothpaste. So yes, excellent job here. Again, bases, they taste bitter. If you ever had your mouth washed out with soap, I hope not, but it's gonna taste bitter. It's awful. I've had it done a couple of times, I'll be honest. And so then obviously looking at litmus paper, it turns litmus paper blue or keeps it blue either way, but it will turn it blue. And again, thinking of soap, it feels slippery. Okay, it feels slippery there. And then finally, the most important thing here, it increases the hydroxide, the OH negative ions in a solution. Okay, they increase that hydroxide OH ions. Okay, so those are those properties of a base. Let's take a look at, are you an early bird or a night owl? Ooh, look at these night owls up here. Oh, Mrs. Larkin, Annabelle, and Camilla. Ooh, definitely night owl. I usually don't go, oh my goodness gracious. Yeah, that's Mrs. Larkin right there. Miles, 2 to 6 a.m. Oh my, I'm in bed by 8 o'clock. People, I was in bed last night at 8:30. Like that, you know, but I'm an early riser. I'm up by like 6 o'clock, ready to rock and roll, ready to take on my day. So yeah, I will definitely say I am a hardcore early bird. Yep, I'm going to go early bird style. Look at that hardcore night owl insomnia. Oh my goodness gracious. You guys are so funny. I am such a weirdo. Mrs. Larkin will sometimes email me and she goes, I haven't gone to bed yet. I'm like, oh, I'm up. I'm ready. I'm ready to go. What can I do? All right, so let's go ahead and hold up. Yep, I did. I changed my hair. Remember, Class Connect sessions are recorded and distributed for learning purposes. Please do not put any personal information or information of others into the chat box for your protection and the protection of others. Make sure you're respectful and make sure you're school appropriate at all times. It must have been a decision I made when it was early in the morning at like 6 a.m. Probably. Maybe. All right, so let's go ahead. If you have gotten your attendance and gotten your attendance word, you need to go ahead and raise your hands for me. If you have not gotten your attendance or attendance word, well, you need to participate in order to get that. Again, just a reminder, you have your first 15 minutes of class to get your attendance in. After that, we will erase the chat box. But you technically still have until midnight tonight to get your attendance. So if you got your attendance word and just happen to maybe want to do it a little later, make sure you copy down that word correctly. Make sure you copy down that word correctly. I'm going to give everybody, let's see, about 20 seconds. This should be pretty easy. 20 seconds up on the board. Go, go, go. I need to see all hands raised. Yep, if you want your attendance, respond in the chat box. What is the property of a base? We just went through it. 9 seconds. I did cut it too, Shelbs. I did. It's chopped off. This is it. No more. All right, there's my little bell. Here we go. Let's take a look here. So, still looking for Ryan, Bryce, Tanner, Kamari, Canyon, Alberto, Alexis, Alan, Christopher. Woo, people are moving up here. Thank you, thank you, thank you. Ryan, Bryce, Tanner, Gabriel, Alberto, Alan, Christopher, Stephen. Let me know, Stephen. I know you work on your cell phone. And Derek, let me know on your cell phone. People are coming into class. And Angela, welcome. Let's get ourselves and our attendance in. Again, if you want your attendance, what is a property of a base? We went through it in the start of the class. So again, let us know. All right. I'm going to go ahead and move on. Mrs. Larkin, if you want to jot down those words for me or those names for me, that would be great. Ryan, Bryce, Tanner, Stephen, and Derek. I don't see Stephen or Derek up there in the chat box. And Angelo and Taylor. All right, let's go ahead and go through our schedule.
Okay, apologies. I was helping students with their attendance again. If you want your attendance, you just need to go ahead and tell us in the chat what is a property of bases that we learned about yesterday. All right, so there are only 5 days left of trimester 3, and then the trimester is over, as well as this entire course. So we are going to go ahead and go over our last content today, which is titrations, and then tomorrow, Thursday, we will be starting our unit, our final exam. There will be a recording that goes over the first half of the exam, so make sure you watch that recording so that you can do really well on your exam. And then there will be on Friday, we'll go over the next half of the exam. So Thursday, Friday, and we will be finishing up our exam. Perfect. Thank you, Christopher, sending you the attendance in your chat. Just a reminder that the trimester does end on this Wednesday, March 3rd at 11:59 p.m., so right before midnight. So you have all of that day, as well as Monday, Tuesday, and the weekend to get caught up on stuff. If you need to get caught up on stuff, please get caught up. Focus on the Unit 1, 2, 3, and 4 projects, and then also make sure that you are obviously doing the final exam. And then don't forget that notes do boost your project grade a little bit, but again, focus on the projects first. There are classes next week, but for next week, we'll be focusing on getting caught up on stuff, and you'll be getting extra credit for coming to class next week. So just so you know, as a heads up for that. And hi, Bernice. Again, go ahead. If you want your attendance for today, you need to go ahead and tell us what is a property of a base. And then Derek, I said you can Google too. So if you don't remember, you can also Google. All right, let's go ahead and keep on moving.
So we are here, our last section of our content, Unit 5. So again, let's see what we're going to be learning about today. We're going to be explaining the neutralization reaction again. We're going to define indicators and molarity. We're going to calculate the molarity of an unknown base solution by completing a titration. And we're going to do this all through our 5C notes. So let's go ahead and, all right, yeah, Taylor, if nobody else can everybody else hear me? Can you hear me, Mrs. Larkin? Okay. Perfect. All right. Yeah, go ahead and just log out and log back in there, Taylor. All right. At this point, what I would like you to do is I would like you to go ahead and open that link that is going to be popping into the chat box. Open it up, start your quiz, raise your hand. Again, if you're watching the recording, click the grades tab, scroll down to the 5C notes and start your quiz. I'm only going to give you about 20 seconds to do that. It should be pretty easy. Quickly, go, go, go. Yes, yes, Gabriel. Everyone's so fascinated by my hair. What is this? All right, get those notes open. 10 seconds, 10 seconds. Don't do my hair usually. Now you see it all done. All right, here we go. All right, so let's go ahead and take a look at this. Ryan, Bryce, Monty, Patrick, Tanner, Canyon, Alexis, Alan, Steven, let me know in the chat box. Kale. All right, I'm seeing people moving up. Again, grab your notes into the chat box, and start opening them up. Kale, Tayan, Jaden, Gabriel, and Bernice. Bernice, let me know in the chat box when you got your notes all open. So last call, Ryan, Bryce, Patrick, Steven, I don't know if you're in the chat box yet. Kale, Jaden, and Bernice, let me know in the chat box. So Jaden, Patrick, Bryce, and Ryan, please open up. Awesome, Bernice. Thank you so much. Thank you. No worries, Stephen. Thank you so much there. All right, so last call, Ryan. Oh, thank you. Thank you, Kale. So Bryce, Patrick, Jaden. All right, I will be checking in with you, Bryce, Patrick, and thank you, Jaden. I see that up. So Bryce and Patrick.
All right, beautiful. Let's go ahead and take a look here. Absolutely. Bernice, let me go ahead and send you the attendance in that chat. Here we go. Again, if you would like to get your attendance for today, please respond in the Q&A area. What is a property of basis? All right, let's go ahead and do a quick brainstorm. So we're going all the way back to Unit 1 when we first talked about solutions. We talked about how solutes are what get dissolved into a solution. So for example, if we have sugar water, yeah, Ame, didn't I get yours? I think I sent it back to you. No. Ame, I said that doesn't make sense. Acids and bases are not the same thing. So try again. If you need to, you can Google it. Okay, so the concentration, so a solute is what gets dissolved. So for example, in sugar water, what gets dissolved, the sugar or the water? Tell me, everybody in the chat, what gets dissolved, the sugar or the water? Awesome. I see Gabriel. I see Shelbs. What is getting dissolved? Yeah, the sugar. So the sugar here would be the solute. Now, we can measure the concentration, the amount of that sugar in a solution, by using something that is called molarity. You probably will notice that the root word here is molar, and that should be very familiar because we talked about molar mass in the most recent unit. And so that has to do with moles. So molarity is defined as the moles of the solute per the volume of the solution overall, and that is measured in liters. So moles of solute goes on top, divided by volume of solution measured in liters on the bottom. Now the units for molarity is a capital M. It must be capitalized. Lowercase m means meters, not molarity. So capital M is our units, and this stands for example, 1M stands for 1 molar. So the units are molar for molarity. So let's go ahead and do an example. What is the molarity of a 1.5 liter solution that contains 0.3 moles of lithium chloride? Go ahead and point for me on the board. What should I be putting on top? Where do I find the moles of the solution? Why can't I undo this? There we go. What is the moles of the solution here that is in my equation? Okay, so is it 1.5 or 0.3? What number goes on top? I'm looking for moles of solution. Moles of solution should go on top. Where do you see the unit moles? You should be looking for the word moles. Where do you see the word moles? There we go. Okay, I see some people correcting that. Thank you. Looking for moles, moles, moles. Thank you. Yeah, it's that bottom number. So 0.3 moles of lithium chloride. That's what I should be plugging in on top. 0.3 moles of LiCl. And what should I be plugging in on the bottom? Go ahead and point for me on the board. Where is my volume of my solution? Again, volume gets measured in liters. Volume gets measured in liters. Beautiful. Yeah, that's going to be the one on top. So that will be our 1.5 liters. 1.5 liters. Let's go ahead, grab a calculator. You will need a calculator to solve question number 4 today. We won't be giving you the answer to question 4, so you do need a calculator. Grab a calculator right now and do that calculation. What is 0.3 divided by 1.5? Again, this fraction is just division in disguise. So 0.3 divided by 1.5, what does that equal? Tell me in the chat. Excellent. I see Miles working. I see Camilla. Let's get some more people. Jadelyn, thank you. Ame, thank you. Perfect, perfect, perfect. Thank you, Annabelle. Yeah, exactly. You should be getting 0.2. And again, the units here are capital M for molar, and the chemical is lithium chloride. So 0.2 molar lithium chloride. Now, you don't need to have this memorized or anything. I'm just showing you where molarity comes from because we will be using the word molarity later on in this lesson. So I just wanted to give you a little bit of background on that. Now, let's go ahead and review neutralization reactions because we also need to know this in order to talk about our topic for today. So remember that acids will neutralize bases in a neutralization reaction. That should make a lot of sense. It literally has the word neutral in it. So for example, an acid and a base will react, and we said yesterday they will always react to form a salt and water. An example here is vinegar, which is our acid. It's specifically called acetic acid. And baking soda, which is a base called sodium bicarbonate. So this is our base right here. Okay. So vinegar and baking soda will react and they will form a salt. Specifically right here, they form a salt called sodium acetate. Not every salt is like table salt, so this is a different type of salt than NaCl. Sodium acetate is a different type of salt. And they also create water, which again, water has a pH that is neutral, a pH of 7, which again is where that term neutralization comes from. We're making neutral compounds here. Interestingly enough, vinegar and baking soda also create carbon dioxide. That's where you actually see these bubbles right here. Go ahead, give me a green check, orange X if this makes sense, talking about neutralization. This is all review from yesterday. All right, beautiful. Give us green checks. Waiting on Monty, Tanner, Michael, Alexis, Ametayan, Jaden, Adriana, Timothy, Omar. Make sure you're using that green check tool on your whiteboard just so we know where you're at. Beautiful. Thank you. All right, we're going to send out attendance one more time, and then we will be deleting the chat. So make sure you get your attendance in. All right, let's go ahead and take a look here. This is going to be number 1. Go ahead and fill in the blank with the word neutralize and only the word neutralize. Make sure that you spell it correctly. You have 20 seconds to get that in and to raise your hand. Go, go, go. Again, attendance will be erased at the end of this part as well. So grab your attendance as well.
5 more seconds. 5 more seconds. Chat box just went out. Chat box just went out. So 5, 4, 3, 2, and 1. Let's go ahead and check in with people. So still looking for Annabelle, Tanner, Kamari, and let's get 100% here. 100% participation. Tanner, Alexis, Tayan, Gabriel. Let me know in the main room if need be. Omar, welcome in. Omar, Bernice, let me know in the chat box. Thank you. Thank you, Gabriel, Alexis, and Omar. Alexis and Omar, you're my last one. And Bernice, go ahead and let me know in the chat. Bernice, if you are A-okay. Everybody else, nice work, nice participation. So Alexis, Omar, and Bernice. Perfect. Thank you. Let's go ahead and move on. All right. So,
what's going on? Okay, so let's go ahead and talk a little bit about indicators. This is something that we took a look at yesterday, and how indicators in pH paper can change colors depending on the pH of the solution. Today, though, we're going to talk about a very specific indicator called phenolphthalein. And phenolphthalein is special because in acidic solutions, it is colorless. In basic solutions, it is bright, bright pink, but most importantly, in neutral solutions, it is faint pink. And today, when we are talking about titrations, which we'll learn about later, titrations require us to neutralize a solution. And it is a hard, phenolphthalein is a hard one to spell. And so it requires us to neutralize solutions, and so we do need it to so we will use phenolphthalein to see when it's neutralized, it will turn faint pink for us. So this is the most important part, that it does turn faint pink. Now, again, we will also be taking a look at molarity and concentration of our acid bases. Just so you know, concentration means that the higher the concentration or molarity is, the more dangerous an acid or base is. So high molar acid or a high molar base, they can both like burn through floors, they can burn through skin. So when we get to that kind of stuff, we have to be very careful in a lab setting. More careful than you should already be being, but you should be pretty careful as it is. So this is going to be number 2. Make sure you fill this in for your notes. Here we go.
Right, so I'm going to give you about 20 seconds to go ahead and fill that in. Get your hands raised. Get your hands raised. 20 seconds up on the clock. Go, go, go. Here we go. Let's go ahead and check in with a few people. Thank you, Bernice. I saw you in the chat box. Awesome. Thank you, Gabriel. Beautiful. Let's go ahead and check in here. Tanner, Christopher, Kale, Ame, Tayan. Thank you, Tayan. Thank you, Gabriel. I'm seeing people moving up. Thank you, Ame. Excellent. So Omar, Bernice, just let me know in the chat box, Bernice. Perfect. And Tanner, my last person. Thank you, Omar. No worries, Omar. Thank you so much. Let's see. You are all good. Excellent. I think we are got 100% there, Mrs. Larkin. Whoop, whoop. All right, here we go. Let's go ahead and move on.
All right, so now that we know about all of this different vocabulary, we can go ahead and talk about today's topic, which is titrations. Titrations are a process, a procedure, or an experiment that we often do in our chem classes that helps us to determine the concentration of an unknown solution by neutralizing it with a known solution. So this is a very, very common experiment that you would see in a live in-person chem class. So if you ever do take another chem class in the future, I want to make sure that you are familiar with this. Okay, so taking a look here, in a titration you have a known solution that you know everything about and an unknown solution that you know almost everything about. So your known solution, you're going to know its identity. In this case, it's going to be hydrochloric acid. You'll know whether or not it's an acid or a base. It literally says it in the name. This one will be our acid. Sorry, your mic is on, Mrs. Sepulveda. You will know the volume of it, so we're going to be starting off with 25 milliliters of this, and you'll also know the concentration, which I believe is 0.1 1969, I think will be our molarity of our hydrochloric acid today. So we'll be seeing that in our experiment, okay? Now, our unknown solution, we already know a lot of things about our unknown as well. We do know that it is sodium chloride today, NaOH. And it has to be the opposite chemical because it's a neutralization. So if hydrochloric acid is the acid, NaOH is the what? Tell me in the chat. NaOH, sodium hydroxide, is our what? Has to be the opposite. We started off with an acid. This should be the opposite, which should be the what? Yeah, this should be our base. Perfect. So this will be our base. This will be the opposite. Okay. Now, we will also know that we will be adding a bunch of sodium hydroxide until we neutralize the solution, and we'll talk about that in just a moment. But once we neutralize the solution, we will write down how much we added. So we will eventually know the volume of our NaOH as well. This is something that we will see in the actual experiment. Now, the only thing we will not know is our molarity. We won't know the concentration of our NaOH, but there is a special equation that we can use when neutralization occurs. I will show you that equation after we see the demo, but there is a special equation that allows us to, at neutralization, calculate an unknown molarity. So that means we need to know when neutralization happens, and the only way that we can know that is with really special instruments, or we can use our indicator phenolphthalein, because again, phenolphthalein will turn light pink when that neutralization happens. So we have to find neutralization. We're going to use phenolphthalein to do that, and then we can use our special equation to calculate our unknown concentration. Go ahead, give me a green check, orange X if that's beginning to make sense. We're going to see this in person, so don't worry, you'll be able to see this a little bit more closely in just a few moments. But just starting off, does that overview make a little bit of sense? Excellent, seeing 15 green checks so far. There are 27 of you. Let's go, let's go. Green checks, everybody, if that's making sense. Perfect. Okay. Yeah, no worries, Monty. Thanks for letting me know. All right, let's go ahead and take a look at the setup here. So our setup is we will have our sodium hydroxide on top here. We will have our HCl on the bottom here. And again, we know everything about these except for our sodium hydroxide. Our base has an unknown molarity, an unknown concentration. So what we will do is within our hydrochloric acid, we'll also have our indicator, which is our phenolphthalein. And so we will be adding drops. You can see drops of base added to this acid until it finally neutralizes. And at neutral, we will see that the phenolphthalein turns this light pink color. So we'll see that in action in just a moment, but let's make sure we understand this vocabulary before we jump in. Here we go.
And indicator. Again, what is the definition? We're going to give you about 15 seconds. The whiteboard tools are available to you. Go ahead and match the term with the definition. Again, 15 seconds. Go, go, go. I see Annabelle, nice job. I see Gabriel, nice job. I'm seeing Shelbs up there. Camilla's up on the board. 1 second, here we go. I'm going to go ahead and put your whiteboard tools on hold there. So let's go ahead and go through this. Excellent job. I don't see too many mistakes. There we go. So titration is obviously the process to determine the concentration of that unknown solution by that neutralization, which is the known solution. Molarity is a measurement of the concentration of the acidic and basic solution. And then finally, the indicator is which changes color depending on the pH of that particular solution. All right. Excellent job. This is the answer to number 3. So hopefully, as I was reviewing it, that you were locking in your answers. I'm going to give you 20 seconds to go ahead and lock in your answer for number 3. Again, if you need more time, take pictures and raise your hand. So 20 seconds up on the clock. Go, go, go. Ira. Kamari, Alexis, thank you. Alan, Gabriel, I see you in the chat box. Thank you, Omar, I see you in the chat box. Bernice, let me know. Tim, and yeah, so Tim, and I think that's it. Alexis, Tim and Alexis. Oh, thank you, Tim. I see you already up there. Perfect. Alexis. Go ahead and let me know with your hand raised. All right, thank you so much. Let's go on.
All right, perfect. So we are going to go ahead and see a demo of this. I apologize. I would have usually done this in person for you with the demo, but because Adobe Flash no longer works on the internet, and this was an Adobe Flash program, I cannot do that. However, I do have a video of me doing this last trimester, so we're going to go ahead and take a look at that today. So let me go ahead and pop this up for you on the whiteboard. All right, and I'm going to go ahead and share this with you. Strong base, that's something that you might do in college. That one's a little bit more complicated. So we're just going to do strong and strong. Again, we're going to fill the burette with what we know, which in this case is going to be our acid. And I'm going to go ahead and choose those. So my acid, I'm going to go ahead and do hydrochloric acid. And my base, I'm going to go ahead and do sodium hydroxide. That is what we don't know, the molarity of NaOH. That's what we won't know. All right, so you can see that down here. Oh, you know what? Sorry, let me go ahead and flip those actually. I lied. Let's go ahead and flip those. Okay, so yeah, so sorry. This one actually has the unknown in here. So we'll go ahead and put the unknown in here. All right, so let's go ahead and again, we'll use phenolphthalein as our indicator. All right, and what we're going to do is we're going to figure out how much of our HCl do we need to add to begin to neutralize this down here. So I'm going to go ahead and actually add a couple milliliters. And hopefully this doesn't turn pink right away. All right. And then I'm going to go ahead and start adding drop by drop. And what you'll see is that eventually this will turn light pink. And sometimes this can take a while, so I'm going to go ahead and add a lot right now. And pause every once in a while to give it some time to mix. In real life, I would be making you do these titrations yourself, and they would take an entire period. So the simulation at least goes a lot faster. Oh, there we go. All right, so you can see now that it is staying light pink. So that means that it is now neutral. So what I need to take a look at here is I need to know the molarity of our acid. Our acid is the known, so we already know its molarity. We know that it started off with 25 milliliters down here. Now, of our base, we don't yet know its molarity. That's our unknown. But we do know how much we added because the pipette here was keeping track of that. So we added 20.18 milliliters of our base. And so using that, we can now calculate the molarity of the base. All right, go ahead, give me a smiley or an emoji in the chat box if that's beginning to make a little bit more sense about what we are doing during a titration. Smiley emoji if that makes a little bit more sense. Perfect. Okay, so let's go ahead and talk a little bit about that. So taking a look here, again, in our experiment, on the bottom we have hydrochloric acid, which is our, yeah, don't drink this though. This is our, let's see here, our acid, right? So hydrochloric acid. And for this one, everything is known. So we know the molarity, which was provided, is 0.1969 molar, and we know how much we added. Its volume was, no volume is 25 milliliters, okay? Omar, to do emojis, you can right click in the text box and then click emoji at the top. And then for our base, that's what we were adding up here. For our base, we do not yet know the molarity. Again, that's what we need to calculate. So we have an unknown molarity. But we do know that in order to neutralize the solution as indicated by phenolphthalein, we eventually needed 20.18 milliliters, which was our volume. So we do know some things about our base. So let's go ahead. Oh my goodness, bad idea, Ame. Let's go ahead and now take a look at our equation that we will be using. So let me jump back over to our playlist here. And let's take a look at this. All right, so again, things that we know, again, the molarity, I'm just going to grab this from the chat box, was 0.1969 molar. Again, we knew that the volume of it that we started off with was 25 milliliters. For our unknown solution, which was our sodium hydroxide, we knew the volume of it that we eventually added to get to neutralization was 20.18 0.18 milliliters, but we do not yet know the molarity of it. However, we can use this very special equation that you need to commit to memory because we will be asking you about this in just a moment, so make sure you memorize this equation. This equation right here we can use during neutralization, but only during neutralization. So this equation can be used only during neutralization between an acid and a base, which is why we needed the phenolphthalein in the first place, because the phenolphthalein told us when neutralization happened. Give me a green check, orange checks if that's beginning to make sense. This equation we can use during neutralization. Beautiful. Awesome. All right, so let's go ahead and take a look at this equation. This equation says that the molarity of an acid times its volume will be equal to the molarity of a base times its volume during neutralization. So I'm going to go ahead and plug these in. I know that my acid was hydrochloric acid, so MHCl times VHCl, and my base was sodium hydroxide, so molarity of NaOH times volume of NaOH. Let's go ahead and plug these in. What was the molarity of my hydrochloric acid? Take a look at my information up here. What was my molarity of my hydrochloric acid that I should be filling in this blank? Go ahead and tell me in the chat. Excellent. I see Shelbs. I see Gabriel. What is the molarity of our acid that we were provided? Yeah, exactly. So we said it was, let's go ahead and put this in. We said it was 0.1969 molar. And what was the volume of acid that we started out with? What was the volume, V for volume, that we started out with? I see Jade Lynn. Let's make sure we're including units too to get used to those. Awesome. I see Shelbs. I see Camilla. Yes, thank you, Gabriel. Yeah, 25 milliliters. That is going to be our volume of our hydrochloric acid. Now, again, after neutralization, we did also know the volume of our sodium hydroxide. So what was the volume of our sodium hydroxide? Take a look at this information up here and tell me in the chat. What was the final amount of sodium hydroxide that I had for my what was the final volume that I had here? Thank you. I see Gabriel. Let's get some more people. Thank you, Camilla. Let's get participation from Kale and Timothy and Taylor. Thank you. I see lots of people. Let's get Jaden. Awesome, Malin. Thank you. Perfect. Looking good. Let's get Christopher in the chat and Canyon in the chat. Thank you, Angelo. Thank you, Omar. Yeah, so 20.18 milliliters. Beautiful. Okay, so let's go ahead and start simplifying this. So on the left, I have two numbers being multiplied. I can do that. Grab a calculator. Tell me, what do you get? When you multiply 0.1969 times 25, what does that equal? Again, you need to be able to finish the problem on your own, so make sure you know how to use your calculator. We're practicing it now, so make sure you're following along with us. 0.1969 times 25, what do you get? Thank you. I see 3 people in the chat. Let's get some more. Again, you should be putting your answers in. You should be checking your calculations because you want to make sure that you're using your calculator right. So double check that you're getting the same thing as everyone else. Excellent. Thank you, Ame. Thank you, Shelves. Thank you, Omar. Yeah, you should be getting 4.9225. If that's not what you're getting for your calculation, make sure that you double check in your calculator. Okay, so on the other side, I cannot yet simplify this because this is just a number and a letter. So I'm going to go ahead and keep this as our letter, our variable, and our number. And this time I need to do a little bit of algebra. So I want to solve for this variable right here, molarity of sodium hydroxide. And I need to get rid of whatever's next to it on this side of the equal sign. So next to it, I have multiplying by 20.18. To get rid of something in algebra, we need to do the inverse or the opposite function. So what is the inverse or opposite of multiplying? Go ahead and tell me in the chat box. What is the opposite function, inverse function to multiplying? Everybody should know this. What is the opposite of multiplying? Thank you. I see Gabriel. I see Annabelle. I see Shelves. I see Camilla. Let's go. Let's go. Get some more answers. Practice this yourself. Let's get Taylor in the chat. Let's get, thank you, Ame. Thank you, Gabriel. Let's get Angelo in the chat. No worries, Ame. Let's get Tayan working in the chat. Let's get Christopher and Alan and Daniel and Canyon and Kamari. What is the opposite of multiplying? Michael, tell me in the chat. Tanner, tell me in the chat. What is the opposite of multiplying? We have 3 minutes left. You will need to be able to finish this on your own, so please work quickly. We still have another question to do too, so I need more participation. What is the opposite or inverse of multiplying? You have several classmates who have already provided the answer. I just need your participation. Let's go, let's go. Thank you, Malin. Thank you, Bernice. Yeah, we're going to go ahead. Thank you, Daniel. We're going to divide. So we're going to divide by 20.18, and that gets rid of it on the right-hand side of our equal sign. But equations are like seesaws. We have to keep them even. So whatever I do to one side, I also need to do where? Whatever I do to one side of the equal sign, I also need to do where? Just like a seesaw? Yeah, we also need to do to the other side. So on the other side, I am also going to divide by 20.18. And this is going to help you get the final answer. Please do not put the final answer in the chat box. Taking a look here, this is the cleaned up version. You need to do 4.9225 divided by 20.18 in your calculator. Your answer should have 4 decimal places, so it should be 0. Blank, 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 blank. So 4 decimal places, just like you see on the board. The units should be capital M for molar. Capital M for molar. Remember that this top number goes into the calculator first. 4.9225 goes in first, then divided by 20.18. If you need to check your answer, we're in the Q&A area, or you can private chat us. You have 45 seconds to answer this. Go, go, go. Raise your hands. We do need raised hands from 100% of you. Yeah, don't forget the capital M. Capital M is molar. So 0. Number with a capital M. That's what yours should look like. 5 seconds to raise your hands. Again, you need to finish the calculation, so grab your calculator and finish it. All right, friends, we are waiting on about 10 of you. So Malin. Let's see here. Tanner. Kamari. Alexis. Awesome, Malin. Christopher, you rounded too much. So you need, and your decimal's in the wrong place. Okay. So double check that. Perfect, Jadelyn. Don't forget your units. Just waiting on Omar. I think I see you in the chat. No, sorry. Omar. Yeah, Omar, I see you in the chat. Gabriel, Bernice, I see you waiting on Christopher, Alan, Alexis. Almost there, Christopher. You just need one more number. Four numbers after the decimal place. Alexis, Alan, Alexis. Please raise your hand. Alan. Alexis, Alan. Hello. Perfect, Christopher. All right. Alexis Allen, last chance, please respond. Alexis Allen, last chance, please respond. Yep, capital M for units. Alexis Allen, hello. All right, looks like we got everyone. Let's go ahead and keep on moving here.
So again, what is that equation we used? We just did it on the previous page. So I'll flip back just for a second. Look at it real quick and let's go back. So what is that equation we use for the calculating of molarity? This is a complete on your own. Please raise your hand, but do not put any answers into the chat box. Use the Q&A if you want to check your answer. Use the Q&A. And my suggestion, my hint, look at the operation. That's all I'm going to say. There you go. Check your answer with Q&A. Do not put any answers. We'll give you about, let's say 25 seconds. Go. Tanner, Michael, Canyon. Thank you, Canyon. Thank you. People are moving up. Tanner, Michael. Excellent. Thank you, Bernice. I see you in the chat box. So Tim, Omar, Gabriel, I see you in the chat box. Jaden and Ame, Michael, Ame, Jaden. Thank you, Omar. So just 3 people. Alrighty, let's go ahead and move on. Excellent job, everybody. So with that being said, today we explained the neutralization reaction. We defined indicators and molarity, and we calculated that molarity of that unknown basic solution by completing a titration. So we did this all through our 5C notes. Awesome. Thank you, Ame. And let's go ahead and stop our recording right here. Excellent. I think we have it stopped on the other end. Let's